guys, this is the last part of our section 6, and so next week we'll be reviewing and taking a test on this chapter. Alright, none of you have sent me an email of the textbook pages, so I kind of remembered what this section was and then gathered some stuff from the internet, and this is what we have. And so we're going to just solve rational inequalities. So your homework won't be from the textbook because I don't know what kind of questions are available in the textbook. So I would really like you to send me the textbook images, or else I will continue to make stuff up until we're done. Okay, so this one, I can actually send you this PDF in the classwork. I will post that as a material because this one is a little bit more systematic in a way that there is a step-by-step way to do this, and it works every time. Whereas other problems that we've been working on, they're a little bit harder to do step-by-step because sometimes it's just very different and it needs a different type of solving problems. So let's look at how to solve rational inequalities. So we've seen this kind of inequalities where we have to draw a number line. And this one isn't all that different because every time you are dealing with inequalities other than the linear inequalities, you will have to draw a number line and check and if it makes sense, okay? Alright, so the first step is solving the equation. So obviously the inequality is written right here. So we're going to solve the equation. And again, solve means make them equal to 0. Well, I guess not 0, yeah. So ignore the inequality for now and then make it equal to 0. And the only way the rational expression can be 0 is when the numerator is equal to 0, right? So then we subtract 3, so x equal negative 3. So that's this step, solve the equation. And then it says determine all values and make the denominator 0. So then we look at the denominator, which is x minus 2. And the only way that makes this equal to 0 would be when x is equal to 2. So we did that. And then the next step is to draw a number line, right? And we've done this before, and then mark the two numbers that you got. And then you have to choose a number. So I'm going to just choose negative 4, and I'm going to choose 0, and I'm going to choose 3. And then you need to plug these yellow numbers back to your inequality to see if it satisfies, okay? So if I do negative 4 plus 3, negative 4 minus 2, well, this is going to be negative 1, 6, negative 6. So it is positive, right? So this is true because it's greater than 0. And then the 0 plus 3, 0 minus 3, this does not satisfy because this will turn into negative. So this is false. And then we plug in 3. So then this one is all positive, so this is true. So then we have to write our answer into interval notation because that's the easiest way to write it. So, and then you use these two numbers, right? You don't use the number you chose, you use the original number. And you see that it's true from negative infinity all the way up to negative 3. And you look at the inequality sign again, and it's inclusive. So that's why you use the bracket. And then union, because it includes its or. And then 2, also infinity. So the reason I use bracket with the negative 3 and 2 is because the inequality itself says inclusive. And that's how you solve the rational inequalities. Alright, so then let's look at number 2. And I'm going to follow the step-by-step again. So the first step was solving the equation, right? So I'm going to set x squared minus 5x minus 14 is equal to 0. So you set the numerator equal to 0. And then this one I need to factor. it's two numbers that multiplies to negative 14, but adds to negative 5. So it's this. So that x minus 7 has to equal 0. X plus 2 has to equal 0. So then x is equal to 7. And x is equal to negative 2. So there are my two answers from the first one. And then the second step was to set the new denominator equal to 0. So subtract 1, x equal negative 1. Now that I have all the numbers, I need to draw a number line. And then put all those numbers in the number line. And then I need to choose some numbers. Negative 3, negative 3 over 2, or negative 1.5, 0, and 10. Okay? And then plug that in to the original equation to see if it's true. So obviously you can, so this is how I do it, okay? I'm going to use this one instead of x squared minus 5x minus 14. So x minus 7, x plus 2. Over x plus 1 greater than 0 is basically what we have right here, right? So let's pretend that I'm plugging in negative 3. So if I plug in negative 3, I don't actually need to solve for the equation because all I need to check is whether or not it's going to be greater than 0. Meaning, would this expression become positive is what it's asking. So we know that negative 3 and minus 7 will make this further negative, okay? And then negative 3 plus 2 is negative. Negative 3 plus 1 is negative. So basically what we have is negative number times negative number divided by negative number, which will become negative still. So then it means that this is false because it doesn't make it positive. Let's plug in negative 3 over 2. Well, let me erase some of them. So we are going to do negative 1.5 basically, okay? Negative 1.5 will make this one still negative. This one positive, right? Because negative 1.5 is smaller than 2. And this one negative. Meaning, negative number times positive number, which is negative, divided by negative number becomes positive. So it becomes true. So guys, yes, of course, if you're using a calculator or something like that, just plug in the number that you see here, the yellow number, to this equation, and what number you get. And if that number is greater than 0, write T. And if it's not, write F. But my goal isn't to really find the exact number, but to see if my number will be greater than 0 or not. So that's why I can do it this way. Without actually finding out what the number is, because that's not what is important. What is important is the sign of the number. Is it positive or negative? So let's try 0. This is going to give me negative number. This is going to give me a positive number. And this is going to give me a positive number. So it's a negative, positive, positive, which makes the overall number negative. So it's false. Last one. Let's try number 10. Sorry, not. So this make it positive, positive, and positive. So everything is positive, so this is true. Which means that the answer for this one is from, do you see how that this is not inclusive? So everything has to be a parentheses. So it's from negative 2 to negative 1, and 7 to infinity, because there is no end right here. Okay? So that's the answer for number 2. Alright, let's look at other types, like number 3. I hope you are getting used to the steps that I'm going over. So the first step is setting the numerator equal to 0 and solve for that. So x equal negative 2. And then we need to set the denominator equal to 0 and solve for that. And this one I need to factor. So x minus 3, I just need to do it once because it's the same. So x equal 3 is another one. So once I have those two, I draw a number line with those two numbers. and then choose some number in between, and then plug it in. Again, I'm going to use the method I used before. So I'm gonna write it as x minus 3 squared. So let's plug it in -3. So then this becomes negative. This will always become positive, do you see? Because it's just something square. So then it's negative over positive. So it is true because I'm looking for something less than 0. And then let's see. If I plug in 0, this will be positive and this will be positive. So this is false. And if I plug in if I plug in 4, it's positive and positive. So this is also false. So the only thing that is correct is from -infinity to -2, because you need to look at the number below. You're not using the number up here. These are just a checking number, and the answer numbers come from the number that you wrote originally on number line. And the reason, again, that this is not a bracket but parentheses is because this one is just greater than or less than instead of greater than equal to and less than or equal to. All right, last one of the day. Number 4. All right, number 4. Start with x squared minus 1 is equal to 0. And this one is factorable, right? X plus 1, x minus 1 equals 0. So then x plus 1 is equal to 0. X minus 1 is equal to 0. So x has to be -1. And x has to be 1. And then the second one is x squared minus 4 is equal to 0. This is x plus 2 and x minus 2. So then x plus 2 has to equal 0 and x minus 2 has to equal 0. So x is equal to -2 and x is equal to 2. So that means I need to draw a number line with these 4 numbers, -2, -1, 1, and 2, and then choose a number. So I'm going to choose -3, -1.5, 0, 1.5, and 3. Okay. I'm going to rewrite my function to be like this because for me this is the easiest way to check if my number would be negative number or positive number. Alright, so my goal is that the number be negative. If I plug in -3, this will be negative, this will be negative, this will be negative, and this will be negative. So everything actually becomes positive, right? Because negative times negative divided by negative times negative is positive. So this is false. If I plug in -1.5, this one stays as negative. Again, negative. But this one will be positive. And then negative. So then there are odd number of negatives. So this is true. Let's plug in 0. This actually becomes positive. This one stays negative. Positive, negative. So there are even number of negatives, so it becomes positive number, which makes it false because I want a negative number here. If I plug in 1.5, it becomes positive, 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 but this one is still negative, so this is true. If I plug in 3, positive, 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 and positive, so overall everything becomes positive, and then that will make it false. So then my answer is from this one, I actually need to use a bracket because it's included, right? So bracket -2, right here, to -1, and 1 to 2. Again, know that I'm using these numbers. Yellow number was just to check. And that is the answer. So I hope that the steps of solving this inequalities help, and then how to write the answers and all that. So I will post your homework assignment as a worksheet on a Google Classroom, and also this notes on how to solve this. I will see you tomorrow, hopefully with your textbook. Bye bye.